topological sorting is used mainly for numbers. Sorting is used for numbers. Okay. But this topological sorting is nothing but this will be mainly used. This topological sorting is mainly done on graphs or networks. This will be mainly done on graphs or networks. Okay. So what is this sorting? Look here, when you have a particular graph, either some nodes will be there, that will be a connection of nodes. Okay. And this nodes will be interconnected with each other with an edge. Okay, they will be connected with an edge. Any number of edges can be there. There can be any connected, and always this topological sorting, this graph, whatever you are using for topology, they should always be directed graph. This you have to keep in your mind. Okay, this is very, very important. Topological sorting works only on directed graphs, not undirected. Okay, it works on directed. For example, look here. This is node 1, 2, 3 and 4. Whenever I have this, I have connected 1 to 2, 1 to 3, 1 to 4, 3 to 4, 2 to 4. Like this, you should have a direction, so that only when you have a direction from one edge to another edge, you can tell it as a direct topological. That is a directed graph. When you have an edge, that is when a U is there, you should have an edge to V. Though you should have an edge to V, and V should be the ending of that. Look here, when I am starting from 1, I'm starting from 1, I'm ending at 2. Okay, that will be a starting node and this will be an ending node. There is an edge from 1 to 2. Okay, that is topology. And another very, very important thing where this topological sorting works is mainly it should be a directed graph, and second one, it should be acyclic. Okay, this is very, very important. No cycles should be there when you have a graph. Okay, why? Because when cycles are there, you cannot sort the algorithm in topology. Okay, so when this topological sorting works only for a directed graph and no cycles. Hence, this topology is known as DAG. That is directed DAG, acyclic graph. Okay, this is known as directed acyclic graph. Okay, so this is known as topology. This is just a topology meaning. Now we will go to the sorting and all. Okay, so this first we will go with the definition of this. I'll just open the notes whichever I have. We will go with the definition of that, and then we will go with the next. What are the important things? How to sort? What are the different sorting techniques? We will go there. Okay, can you see the screen now? Can
Yes,
you see?
ma'am.
Okay, now look here. This one. What is this? Look here. Topological sorting. Yarado, mute yourself. Who is that? Okay. So if we have a directed graph G, look here. If we have a directed graph G, then topological sorting or ring of a graph is called a linear order of the vertices of the graph such that, okay, so this topological ordering, what is the definition of this? It is nothing but a linear order of the vertices of the graph such that UV is an edge in the graph. Then, okay, one should come before, that is here U is there. U should come before V in the topological ordering. Whatever I told you, there will be an edge from U to V. U comes before V. That is, for example, I take 1, 2, 3, 4. 1 is coming before 4. 2 is coming before 4. 3 is coming before 4. Like that, there will be an order. There will be a linear order of vertices. Okay, that is known as topological ordering or topological sorting. Let us assume that a student has to take 5 courses subjects before he gets to a degree, and they can be repeated. as below, like look here, as below deficiency graph. In what order he will study the courses? For example, now look here, C1 is there. This is course 1, course 2, course 3, course 5, course 4 and course 5. So now I have to take this as a order, as a topological order, and I have to show in which way the student has to select the courses. Can you tell me, according to your knowledge, normal generally, without I am using any techniques like sorting techniques, what should be the order of the normal selection of subjects over here? Anyone? These are the 5 different subjects or 5 different courses. For example, you can take your 4th semester subjects, subject 1, 2, 3, 4, 5. In which way, in a linear way, you will go with the subjects when you have want to select the subjects? Am I audible?
Yes, ma'am.
Yeah. Tell me in what way you will select the subjects.
Ma'am, C1, C3, C4, C5, C2.
Yeah. You can go with like that. C1, you can go C3, you can go C4, you can go C5. Then you can finally come to C2. But the ordering should be linear. That is linear way you have to go. That is one after the other only you have to go. You can even select that way. Whatever I do, I even look here, there is no any incoming from C1 or there is no incoming to C2. Even I can go from C2 also, right? C2, C3, C4, C5 I can come. C1, C3, C4, C5 I can come. Or else even I can come from C1, C2, C3, C4, C5. Like this also I can come. Anyway, you can select the order, but it should be in a linear. That is, 1 should be selected after 2, 2 should be selected after, that is 2, then only 3, then only 4, then only 5. Like this, there should be linear order from one selection to another selection. This is just a simple example. We will see how to do that. Okay. For topological sorting to be a possible, a graph must be, look here, this is very, very important, directed acyclic graph, DAG. We call this as DAG in our normal networking terms. DAG is nothing but directed acyclic graph. This, look here, this graph. There is a directed graph. Okay, there is a direction. C1, C3, C4, C5. From again, there is no connection from C5 to C3, right? If there is a connection back from C3 to C5, there will be a cycle. If cycles are there, you cannot find out the ordering for, because look here, C3, C4, I'll write and I'll show this why we cannot use for cyclic graphs. I'll show that. Okay. Now look here. Being a DAG is not only necessary but also sufficient for topological sorting to be possible. This is very important. For topological sorting, always a graph should be directed and it should be acyclic. Okay. There are 2 efficient algorithms that both verify whether digraph is a DAG, that is directed acyclic graph, and if it is procedure and ordering of vertices, that solves the topological sorting problem. So this is just a extra thing they have given. Okay. Now, especially the very, very important thing what we come to know from this definition is there will be an edge from U to V, so that U will be a starting edge, V will be an ending edge. Okay. This is what very, very important thing we should note down. Okay, so that is one thing, that there will be an edge from U to V. U will be the starting edge, that is U should come before V. That is very important ordering of topological, and topological sorting can be done only on directed and acyclic graphs. Okay, and to do this topological sorting, we will be using 2 different algorithms. One algorithm is depth first search. You people have already studied this in your data structures. Okay, the way now we will be same thing like stacks and all we were using. Do you remember we used stacks and we did this DFS, BFS? Do you remember in data structures? Same thing, but here it is very simplified graph compared to that. No need to write that full big array, and no need to do that. Okay, this is a simple thing, same procedure we will follow. DFS is the first algorithm. Second algorithm is source removal algorithm. Okay, Second algorithm is source removal algorithm. Okay, so this is what now I will share the screen with notepad. We will go with the two important algorithms. Okay, can you see the screen now? ಕಾಣಿಸ್ತಾ ಇದೆಯಾ?
Yes, ma'am.
Okay. So these are the important two things you people have to note down. That is, there will be an edge from U to V. You will be a starting edge and we will be always ending edge. It should be linear way. That is, one, for example, 1, 2, 3, 4. 1 comes before 3. 2 comes before 4. 3 comes before 4. There will be a linear ordering of the edges or vertices, and there will be no cycle. This is very, very important, and it should be directed graph, DAG. Okay, and two important sorting algorithms we will be using in sorting algorithms. We will be using to sort the topological graphs. That is, first one is DFS, depth first search, and second one is source removal algorithm. Okay, now we will go with DFS first. Okay, so you people already know this DFS. Mainly this DFS, we will be writing this DFS using stacks. Okay, you already know this. I have taught this in your data structures. What we do, first thing is what we do whenever we visit a node, we push this onto the stack, right? Push this onto the stack. Next is very, very important thing. After visiting the node, we have to see the adjacent nodes of that source node. Okay, see all the adjacent nodes of that source node, and after this visit adjacent nodes and put on the stack. Okay, do this, repeat this for all nodes. Repeat this for all nodes. Once you reach a condition where you'll reach a condition where you will not have, there will be a one vertex or one node where that node won't be having any adjacent nodes. At that time, you people have to stop moving to the adjacent nodes. Okay, so when you stop moving to the adjacent nodes, what happens? When you stop moving to the adjacent nodes, then you people have to pop the nodes from the stack one by one. This is what we did in our previous this thing, right? Okay, so visit adjacent nodes and put on the stack. Repeat for all nodes. Okay, once you encounter a dead node, that is, dead node is nothing but which is not having no any adjacent nodes for this. Okay, no any adjacent nodes. This is not there in your notes. This is just I'm explaining before going to that graph. No any adjacent nodes. Okay, put that when dead node is encountered. Start popping. This is what very, very important procedure for DFS. Okay, first visit a node. After visiting a node, why this is happening? Okay, first visit a node. After visiting a node, see that any adjacent nodes are there for that. Once you visit a node, push that node into the stack. Okay. See any adjacent nodes are there for that, and visit that adjacent nodes also. Then put that onto the stack. Okay. Put that node also onto the stack. Like this, repeat for all the nodes. You cover everything. All the adjacent nodes have to be covered for each and every node. Once you encounter a node where there will be no any adjacency or no any neighbor graph for that, adjacent graph for that, stop there and start popping the nodes from the stack. Okay, we have to do this, pop everything until the stack becomes empty. Okay, and finally you see we have visited all the nodes or not. If we are not visited all the nodes, again start it from the node which you are not visited. This is what the very important thing for DFS. I'll explain with a simple example, then it will be easy for that. I'll go with a new page. Okay, so I'll just explain example. Can you see this? Are you able to see this?
Yes, ma'am.
Yes, ma'am.
Okay, now we will take the same thing course, whatever the example we had given, there is example in your textbook. We will take this one only, C1, C2, C3, C4, C5. Okay, so there is a direction from C1 to C3, C2 to C3, then C4 to C3, C4 to C5, then C3 to C5. This is what a directed acyclic graph. Look here, there is no any cycles for this. When you have a cycles, look here, for example, there is C3, C4, C5. For example, I am telling you, there is a cycle over here. For example, look here, there will here direction is from C3 to C5, but here I have written from C5 to C3. This is a cycle, right? When you have a cycle, for example, you can travel from C3 to C4, C4 to C5, right? Again, you cannot judge that from where I am going and where I am ending. You will be in a cycle. There will be no dead end here. There will be no dead end. Okay. Once you don't get a dead end, you cannot stop anywhere here. You will be in a cycle. Keep on repeating. C3 again go to C4, again go to C5. You cannot tell which is first one, which is the last node, right? Here you can start from C5 also. You can start from C3 also. You can start from C4 also, right? You can start from wherever you want, and there is no any ending point for this. There will be any dead node only, because all the nodes are having the adjacent nodes. Once you don't have a dead node, you cannot stop the topology over here. So always see to that you cannot use this topological sorting for a cyclic graph. This is very important. Okay, there should not be any cycles. Look here, there is no any cycle over this. This is what important thing we need to know, why we use only for acyclic graphs. Okay, now we will see the procedure, how to do this procedure. We will see first one. Very important thing is, first we will start with a node. Okay, now I will start with the course. I will start with C1 only. Okay, now we will take, there will be a stack over here. Okay, we have to take stack, that is we have to push and pop. This is very important for this. Okay, now I will start with C1. I have encountered C1 node. Okay, I have encountered, now I will start from here. I will encounter C1, and look here, as soon as you encounter one node, look the adjacency of this node. What are the different adjacencies of this node? Now you have come to this node, you are visiting this node. As soon as you visit this node, always push that onto the stack. Okay, I will push. Look here, push and pop will be both. This is just for moving purpose. This is just for showing you how we move. Okay, and this is for stack. Push and pop will be there. Okay, now as soon as you encounter a node, you have to push that onto the stack. C1. Okay, and keep on writing the numbers. This is the first node. You have to write the numbers. With the numbers only we will come to know this very easily. Okay, now after putting that onto the stack, after visiting, now very important thing what you have to do, you have to see what are the adjacent nodes C1 is having. Can anyone tell me what is the adjacent node C1 is having now?
C3.
Yes. So C3 is the adjacent node for C1. Look here, this arrow, whatever I am writing, this is a connection only. This is an edge, not just an arrow mark. This is an edge. This is the edge. Okay. Now you have to see that C3 is having, C1 was having adjacent node C3. I have visited C3. Since you have visited C3, mark that in, that is push that. Always pushing will be from what? Stack will be, top will be here. Top keeps on incrementing. You have to put on the numbers which are above, right? Push is like stack is like this only. On the top of the stack you have to put. So now I am visiting C3. I am putting C3 onto the stack now. Okay. So this is the which node? This is the second node I have put onto the stack. Now go to C3 and now look here. I have visited C3. Now what are the different edges for C3 you have? What are the different adjacent nodes? You have C4 and C5. Just right here. C4 comma C5 are the two different adjacent nodes you have. I can go either to C4 or even I can go to C5, but we will follow the linear way, that is numbering. It is very important. If it is A, B, C, D, I should write A, B, C, D, E, F. In a linear way you write. It will be very easy for you to sorting. So in a linear way, if I go, I will go to what? C4. Now I will go to C4 from C3. Okay. Now I have visited C4. So as soon as you visit that, put that onto the, push that onto the stack. Okay. Now I have visited C4. Now for C4, what is an adjacent you have? C5, right? From C4, there is an adjacent node C5. So write that here C5. Now from C4, visit C5. Then push that onto the stack. Okay. I am pushing that onto the stack. Now, do the C5 have any adjacent nodes here? Answer. Is C5 is having any nodes after this? C5 is connected to any other nodes from
No,
C5?
ma'am.
Any other node is going
No,
outside?
ma'am.
No.
No, ma'am.
Now this is a dead node for me. Okay, when you encounter a dead node, you should stop here. That is, you should start popping from the stack. Okay, when you encounter a dead node, pop the elements from the stack. Okay, how you pop? Always what? Pop ಮಾಡುವಾಗ ಹೆಂಗ್ ಮಾಡ್ತೀರಾ? Whether you're doing from the top or you're doing from the down, pop should be from what? What is stack? Stack is
Top.
what?
Top,
Last
ma'am.
in, first out. Okay, this one has to be popped now, right? Go from this thing, you have to pop. So now popping, that is, now what happens now? First C5 is popped. Till until you encounter all the nodes have been visited, again you have to go back now. Okay, now once I encounter a dead node, I have to go back, check whether any adjacent nodes are there for that. See any adjacent nodes are pending, that I have to do now. Okay, so now I have encountered a dead node C5, so that I have to pop this from the stack. So while you are popping, write the number. This one will be the first node to be popped. The numbers are very important for us. Okay, now encounter, I have popped C5. Now what is the next one is C3, C4. Now go to C4. Is C4 having any remaining adjacent nodes? Only C5 is there. We have already visited C5. No any adjacent nodes are there. So pop C4 also from the top of the stack. Okay, again go to C3. After popping, C3 is there. Okay, now C3, how many nodes are adjacent? C4 and C5. Already C4 and C5 were visited, right? C4 and C5 already visited. So pop this also from the top, from the stack. Okay, now again go back to C1. Is C1 having any other node? C3. Is C3 already visited? Yes. C3 is already visited. No. So now C1 is also dead node for me. Pop this from the stack. Right? So I have popped everything. Now the stack is empty for me. Stack is empty. Okay. Now look here. All the nodes whichever are there in this line, I have visited everything. Now see the graph also. I have all the nodes visited in the graph. Still any node pending, we have to see that. Any node pending?
C2 is pending.
Yes, because I have not visited C2 still now. So now again I have to start this from the beginning. Okay. Now I have to start with C2. I will take C2 now. Okay, like this we have to do for big graphs are there. We have to do repeat the same process. That's all. Now C2 I am taking. Does C2 is having any adjacent node? Yes. Now as soon as I visit this, you have to put that onto the stack. Always remember now stack is empty. No? C2. Okay, pushing, that is push idelu numbering napka itkoli. C2 is now what I am putting fifth node I have to put onto the stack. These are the numbering of nodes, that's all. Okay, this numbering you should keep in your mind. This is very very important. This is push and this is pop. Okay, ಇಲ್ಲಿ green ಅಲ್ಲಿ ಬರಿತೀನಿ ಅವಾಗ ಗೊತ್ತಾಗುತ್ತೆ. This numbering is push, this is pop. Okay, now I am pushing C2. That is C2 is the last node, that is fifth node I am pushing onto the stack. Even though the stack is empty, for me it is fifth node, right? So write that number here. Now, see to that. I have pushed C2. Now, which is C2 is having which node as an adjacent? C3. Now write it here. C3 is the adjacent node for C2. Have C3 already visited? You have to check that whether C3 is already visited. Yes, there is a node from C2, right? C2 is having a node to C3, but C3 is already visited. Okay, so now you can stop here itself because now C2 has become dead node for me. Nothing. Now already C3 is visited. So from C3, C4 is there, C5, all these nodes are already visited. Now there is no any node from C2. No node from C2. Look here. Is C2 having any other node apart from C3? No. So C2 is encountered as a dead node. Once this is encountered as a dead node, what you have to do? You have to pop it from the stack. So pop this from the stack. Remove this. So remove this. When you pop this, what will be the now 1, 2, 3, 4. This is the last fifth node I am popping from the stack. This numbering is very, very important. Okay, what numbering now? Pushing and popping. When you have this numbering, popping is very, very important. That order we have to consider. Okay, look here. Popping order any there? This one. 1, 2, 3, 4. And finally this one. 5. Okay, now I will write an order over here. I will write that order. So what is that order now? Which one was the first pop from the stack? Here, order. You have to tell me the order. Which node was the first pop? Tell me. This is the node C5. Then, which is the next popped? C4. Next popped C3. Next popped C1. Next popped C2. This is the order. First popping order we have to write. This is very important. Now, after writing the popping order, okay, this is the popping order. You have to reverse this. Reverse this popping order. You have to reverse this popping order and write C2, C1, C3, C4, C5. That is reverse the popping order. Okay. So when you reverse this, this is the sorting algorithm. This is a sorted answer for the graph. This will be a topological order. Understood? This is how we will do using DFS. Artha aita? You have
Yes, ma'am.
the graph. You
Yes,
have to
ma'am.
see what are the different adjacent nodes of that particular node. Go write that here. Like this, you write the adjacent node and travel that node. As soon as you visit that node, push onto the stack. Okay, and write the numbers. Pushing and popping is very, very important. Then see the next adjacent node. For that, any adjacent nodes or travel everything, all the adjacent nodes. Once you get the dead node, start popping. That is, pop everything. Go back, pop there, go back, and see that any other adjacent nodes are there. If any other adjacent nodes are there, push. Again, pop. Like this, you people have to do this. This DFS repeats until all the nodes are encountered and all the nodes are traveled, and finally all the nodes, there will be one node where will be dead node. Okay, once you encounter a dead node, pop it. And the popping number is very, very important. Whatever the popping number you write, that will be the order of the very, very important topological sorting. That order, you write the nodes and reverse that, that will be your topological order. This is the technique whichever you have in your textbook to follow the DFS. Understood?
Yes, ma'am.
You can apply the same for any big graphs also. Okay, so this is first important technique. Next one, we will go with a very, very important next topic. Zero removal. This was the first one. Okay, this is the first sorting technique whichever we are doing, that is first sorting algorithm is DFS. Okay, now we will go with the second sorting algorithm. What is the second sorting algorithm we encounter? What is the second sorting algorithm we saw? Source removal algorithm. Second algorithm is source removal algorithm. What is the source removal algorithm? Very, very important thing in source removal algorithm, we have to see incoming edge and outgoing edge. This is very, very important here. Okay, we have to see how many incoming, that is numbers, always this will be number. How many incoming edges are there? How many outgoing edges are there? We have to see the first one. So after seeing the incoming and outgoing edges, the zero, whenever the node which is having zero incoming edge will be removed. Okay, the node which is having zero incoming edge will be removed, and we have to write the new graph every time. Once you remove the node, new graph should be written every time. This is what a procedure for source removal algorithm. Okay, I'll just write an example and I'll show you. It will be very easy for you. Once you see an example, it will be easy for us how we are doing this. Okay, I'll take one simple example. Even we can take the same example, whatever we have written. We'll just say one more example. For example, this is one graph. Okay, now I have to find out the topology. They will ask you, they will give a graph like this and they'll ask you, use topological sorting with the help of source removal algorithm. Okay, so very, very important thing, when you have a graph like this, you have to see the incoming edges and outgoing edges. You have to mark them. Okay, how many incoming edges are there, how many outgoing edges? Especially we will go with incoming edge. Very, very important. This is very important. Incoming edge. Okay, so can you tell me here, look here, this is a graph now. This is the first vertex. How many incoming edges are there for this? I'll write the numbering over here. How many
0.
incoming edges are for there? So for one, there is
0,
0.
ma'am.
And now Okay. For 1 it is 0. And for 2, how many incoming edges are there?
1.
1. Okay. And then for 4, how many incoming edges are there?
2.
4 is having edges from 1 and even 2. 2. For 3, how many incoming edges? 2. For 5, how many incoming edges?
1.
1. So this is very, very important thing you people have to note down. Now, after writing the incoming edges like this, first what we have to do, we have to see which vertex is having 0. Which vertex is having 0 incoming is removed. Okay, now 1 should be removed from the graph. Remove 1. Place it here. 1 is removed. Or else I'll just write a number. Remove 1. Okay. As soon as you remove 1, what happens now? This whole thing, this whole part of a graph will be removed. This is removed. Okay. Now what is the remaining part of a graph? Okay. Now we have to remove the vertex which is having 0, and I have to again rewrite the graph. Okay, this is very important. Now 2, 4, 3, 5. Okay, look here. Now again for this graph, again we have to see how many incoming edges are there. So now tell me for 2, how many incoming edges are there? 2 is having 0, 4 is having 1, 3 is having 2, 5 is having 1. Right? Now again from this graph, remove the vertex which is having 0 incoming. So now I will remove 2. I will write here, I will remove 2. I have to remove this. Remove this. After removing, again what will be the new graph for me? Again new graph is 3, 4, 5. So from 2 this edge is removed. This edge is removed. Right? Only these are pending. Okay. You have to remove the edges also. So from 3 you have only this one. Finally, you have only this from the new graph. Okay. Again, now see the incoming edges of this. So for this, how many edges are there? No incoming edges are there. Sorry, incoming edges there for this. Okay. So for 3, how many incoming edges are there? Tell me. 3 is having 1 edge.
1.
4 is having 0 edge. 5 is having 1 edge. Okay. Now again, remove this. Remove this. So remove 4. I'll write here. Now after removing, you have to remove this edge. This edge is also removed. This edge is also removed. Now in graph, what are the different nodes? Only remaining nodes are there. 3 and 5 is there. There is no connection from 3 and 5. Now you can either remove 3 or you can either remove 4, 5. In any order you can remove. You can remove 3 directly and put here, or you can remove 5 and put here. Any two possibilities are there. So I will remove 3 first, then I will remove 5. Or even you can write 1, 2, 4, 5 and 3. Anything you can do. Both are correct. Because look here, how I can remove, because now look here, 3 is there, 5 is there. 3 is also having 0 incoming node, 5 is also having 0 incoming node. So I have to remove both and I have to put onto this. So now you can either remove 3 or you can either remove 5. That is left to the user. You can do anyway. So this 2 is the order for the graph whichever we have.